All right, on the handouts, you had numbers 2, 3, 17, 21, and 23 from last night. The first one, we had an x negative y equals -1 and a 2x positive 3y equals 18. Other than graphing, which we ain't going to do, we really have two ways to solve systems class, either substitution or elimination or addition. All right, in this case, I already see them lined up. And for me, it'd be super easy just to multiply the top by a 3. 3, 3, and 3, which would allow the y's to cancel, giving me equals 15, so x equals 3. If I go back to the original x minus y equals -1, and I plug in the 3, 3 minus what equals -1? Or we could double switch. We could bring the -1 over as a positive and send the negative y over as a positive to get y equals 4, because 3 minus 4 equals -1. However you choose to get it, should have had 3, 4 as the answer. Could have certainly solved by substitution, right? Move the y over as a positive and replace y minus 1 in place of the x here. Either way is fine as long as you got 3, 4. How many got 3, 4? Those who did it. All right, you did it as well.
I did it before you finished.
Oh, okay. Show off. All right. Let's take a look. Good job. All right, let's take a look at number 3 as well. Here we have a 3x minus 4y is equal to 14, and an x negative 4 is equal to 2y. Here I don't have them lined up, and for me, maybe easier just to move the -4 over class as a positive 4, and then just replace this x with 2y plus 4. Now, of course, once I replace it, what am I going to have to do with the 3 class? Distribute to get. And then, of course, I still have this -4y, and I still have this equals 14. We can combine 6y plus 12. There we go. Combine the 6y and the -4y. 2y. Also, move the 12 over as a negative to get 2, and so y equals. And the nice thing about the substitution method is it's easiest to solve for the other variable because it's already set up. Just 2 times 1 plus 4, 6. And we end up getting 6, 1 for our answer. How many had 6, 1 for the answer there on number 3? All right, question. Did you do substitution or elimination? Did you do what I did, move the 4 over as a positive to get 2y plus 4?
Wait, no, I did elimination.
You did elimination. So you brought the 2y over as a negative and sent the 4 over as a positive to get x minus 2y equals 4 for your lower equation. I assume you multiplied bottom by 2 maybe?
Mm-hmm.
To get 2x negative 4y equals 8, and then you had to change the signs in one of the two equations. Top or bottom? You did the top. What did you end up getting for your x?
I got
2/3. All right, so you should have had a -3x positive 4y equals -14, and you had a 2x negative 4y equals 8. That cancels. You end up with a -x equals -6. So I'm not sure what happened there. All right, let me see your work. Any questions, comments from anyone else while I'm looking at her work? Oh, goodness. Okay, you lost your x. Your x disappeared. You did do You did do the substitution method. You divided a 2 from everything. I hate fractions. Don't ever make fractions. Yeah. So, for instance, again, let me show this again. If this is the equation, the letter you want by yourself is the one that's already a lonely letter. This y isn't lonely. It's got a friend. The x is lonely. Only the lonely letter gets by itself. I'm never making fractions. Like, I'm not getting the x by itself because I'd have to divide a 3 and that makes fractions. I hate those. I'd have to divide away a 4 at some point. Not doing it. Hate fractions. Make sense? All right, good. Any other questions on systems of equations? We're going to look at the rest of the homework in just a moment, but for now, clear your desk except for a clean sheet of paper, pencil, and calculator. We're going to go and take a quiz, and then after the quiz, we'll finish looking at the rest of the homework, because frankly, the kind of stuff that was on the rest of the homework ain't going to be on the quiz. So, sheet of paper, pencil, calculator, everything else away. First of all, let's name the top of your paper, along with today's date, which is 2/25/22, 2/25/22, or if you write it backwards, 2/25/22. 10 months till Christmas. You've already been planning your Christmas shopping for your favorite teacher. Can't buy 37 presents. First last name at the top of your paper, along with today's date, 2/25/22. Let's go and take a look at the quiz together very quickly here. And numbers 1 through 5, completion, write the word that best completes each statement. And then for 6 through 9, solving for x and y by whatever choice or whatever method you choose. I'm going to put a bonus on the chalkboard for you as well. I'm just going to put a bonus on the chalkboard if you have time to work that. To the best of your ability, to use that quiz copy as a cover sheet. as you work. Try to be finishing up in the next few minutes. Just a few more minutes to be finishing up. Again, once you're finished with the quiz, there's a bonus problem on the chalkboard you can copy down and do as well. Once you finish, turn your paper over, sit quietly. Just keeping your work covered. I'm going to collect that from you. If you need a little bit more time when you're watching on YouTube, you can pause the video, but we're going to go ahead and get started finishing looking at our homework. So we'll take a look at those quizzes on Monday. Get your homework back out, if you will please, those handouts back out, and we're going to look at numbers 17, 21, and 23. Obviously, the quiz didn't have any rational systems there, but we did want to practice with some of those now, because the next quiz likely will. Number 17, They gave us the equation 3x over 4 plus 2y over 3 is equal to 20. And then x halves plus 3y fourths is equal to 17. And what did we need to do here, Kendall? Yeah, multiply everything by the LCD individually though, right? We don't have to say, well, what's the LCD of all of it collectively? Just for the top, the LCD is.
12.
And just in the bottom, the LCD is.
4.
So when we multiply 12 all the way through the top, including here, this is the single biggest mistake I see is students who forget to multiply by the last number. What do we get, Kendall?
9x plus 2y.
We're multiplying, so we're going to
8y.
cancel
8y.
8y.
Equals 480. No, 240.
240. Did you multiply by something other than 12?
I was looking at the.
Okay. So let's say, okay. So for redemption here, let's try this again. In the bottom equation, we would have to multiply everything by 4, and what did you get, Kendall?
2x plus 3y equals 16.
Excellent. And now that the fractions are gone, I'm going to kind of use this as my starting point here. I don't like the substitution method. I don't want to have to get anything by itself because it makes nasty fractions and I hate those. That said, I'm not too crazy about the elimination method either, but you know, it is what it is. Maddie, assume you eliminated and you got rid of the x's. 18 is still smaller than 24 by a little bit, right? So top equation only by, which is nice because there's already such big numbers here. Bottom equation, yeah, I got to multiply by 9. So what does this top equation become now?
I did the top by
Negative 2, okay.
negative 18x equals 6y.
480. All right. And the bottom equation by the 9.
18x plus 612.
612. All right. And so I don't know if she just had the foresight of knowing that she was going to have smaller numbers up here because multiplying a 9 was just going to make them bigger or what. But anyway, it worked out great. Where we do have the smaller numbers on the top, we'll cancel the x's. Genesis here, the 27y minus 16y gives us, and then we got a 612 minus 480 to get 132. That's actually not so bad because this was on our 11 times tables as kids. Class, we divide both sides by 11, we get y equals 12. Again, I don't want to go back to where the fractions were with my 12. It was 12, right. And so I'm going to take that 12, Brandon, and we're going to plug it in for y in either the first or second equation. Second equation has little numbers. I like little numbers. 3 times the 12. We're going to subtract away the 36 to get 32. And if 2x equals 32, then the x equals 16. And there's our answer, 16, 12. How many had that? For number 17. All right, questions at all? Let's take a look at number 21. And top equation, we're going to multiply everything by what, Michael?
For 21?
Yes.
6.
6, bottom equation by
3.
I think you can do this in your head, Michael. Top equation by 6, what do we get?
6x plus 2y, 2y equals 6.
Yeah, I think it's 7x, but I know what you meant. Plus 2y is equal to 6. Bottom equation by 3, I know you can do this in your head.
X plus 3y equals 28.
There we see, I knew you had it in you. And Michael, we're going to let you pick, because I could do a substitution here, or I could just roll with addition. What are your thoughts?
I don't know. What do you prefer?
No, I'm going to let you pick.
Can I phone a friend?
No. You've got to make these tough decisions in life.
Substitution.
Substitution. All right. So we're going to take the bottom equation, right, and we're going to rearrange it to say what?
X equals 28 minus 3y.
All right. And then we're going to take this 28 minus 3y and go back to the other equation, remember, and put it where it says
7 times the quantity of 28 minus 3y plus 2y equals 6.
And I'm not even going to make you suffer with your own decision because I'm going to make Audrey distribute the 7 for us here. And Audrey, when we distribute the 7, what do we get?
Sorry.
196 minus 21 plus 2y equals 6.
There we go. Of course, we can combine our y's together to get,
Negative 19.
and we're going to ditch that negative 19 over here as a positive 19y, because I hate negatives. And meanwhile, I'm going to bring the 6 over as a negative to get 190. Hey, that's not bad. So we end up getting, Maddie, y equals, this time I did it on purpose. And so we're going to take that 10. Now again, the upside of the substitution method, although yeah, you're multiplying by 7, maybe you'd rather not do that. But the upside is a back end. Really easy. 28 minus 30, class. Negative 2. So I get my negative 2 tan for our answer. I don't think I did that quite right. And get this answer here. How many had negative 2? How does it go again? Tan. All right, negative 2 tan. How many had that for your answer? Brecken's like, he'd be picking on me if I was. Yes, I would. Questions? All right, and the last one was number 23. And in an x negative 1/4 plus y equals 3, and an x negative 1/4 plus 4y equals 9. Abby, again, no, you didn't have to do it because you had the pass, but comments rather, thoughts.
Alright,
Substitution, and what are we going to substitute for?
for the x negative 1/4.
Absolutely. Let's take this whole x negative 1/4. Let's get it by itself by just moving the
Y over as
As-
negative.
and let's take this 3 minus y and put it where it says this. So my bottom equation really becomes easy quickly.
3 plus 3y equals 9.
Okay, there we go. 3 minus y, then plus the 4y equals 9. In case you didn't see where that came from, but she went ahead and combined in her head. Equals 9. And now you can solve it in your head and get y equals
2.
2. Really, really easy to get the y value. Now the downside is, in this equation that we rearranged, it's going to be a little bit more involved, I guess, to try to get the x, but not too bad, right? We plug the 2 in here, class. Well, 3 minus 2, 1, and x minus 1 over 4 equals 1. Multiply both sides by 4. That's going to give me x minus 1 equals 4. What minus 1 equals 4, class? 5. So x equals 5. Not a problem at all. Those who did do it last night, how many saw that the x minus 1/4 could just work together there? Anyone see that? All right. How many got 5? 2 at least. Oh. Questions? Okay. By the way, we could, if we wanted to, use the addition method here, and it's going to produce basically the same result. So I wanted to show that as well. If you went through, somebody was messing with my chalk. I feel like, you know, the Goldilocks and the Three Bears. Somebody. Anyway, so Kendall got it. Thank you, Kendall. I needed that. All right. So we could go through and just change all the signs, and notice that'll just knock these fractions right out. There's a 3y equals 6. Y equals 2. Now again, that's going to make it slightly more involved on the back end, but not bad, right? Either way, plug it in here even, right? That's 8, subtract it to 1, multiply the 4. You know, so some things we could do there to make our life easier. Questions on number 23? Any questions at all on rational systems? Questions on the rational systems? Systems with fractions. All right, if you did not mark on your handout and it's still in good condition, and you're not super emotionally attached to it, I'll collect it back. If you say, I worked hard on this handout, I don't want to give it up, and you hold on to it, that's okay. I don't want to scar anyone emotionally, or if you graffitied all over it, then I don't want it back either. But, you know, I'm lazy and don't like to print more of these.
I can write small, and you can see all the
That is not, I am not judging. There is no problem with that. Good job. All right, but I save myself some printing in the future.
You're welcome.
Thank you. All right, go ahead and have your notes out. We're going to work some systems, or some word problems rather, that are involving systems here. So let's take a look at some more of these. We were working on these the other day. And go ahead and read the first problem aloud for us, if you would, Brandon.
A large number is 1 more than 5 times as large as a smaller number. If 10 times the smaller number is subtracted from 3 times the larger number, the remainder is 38. Find the two numbers.
How many unknowns, obviously?
2.
And what are the two unknowns?
Number 1, number 2.
We could do that, though it actually does refer to them specifically as being
Large and small.
large and small. We wouldn't want to get confused with something else. All right, right across the hall there, across the wall there, the 3-year-olds would think you were talking about something else. Alright, so anyway, we've got a large number and a small number. And we're not going to pick one, right? I almost out of habit said which one gets to be x. Michael just got it.
I got it.
Number 1 and number 2.
I
Anyway.
got it.
There's a bathroom right there, Roger.
I still lost.
You'll have to tell Miss Davidson. She'll explain it to you. Alright, anyway.
Here's a minute.
Oh.
It wasn't that good of a joke, really. We'll just flush that joke and we'll move back to our number. Alright, so normally we have to pick an unknown to be x. We don't have to do that because whenever, this point forward, we have 2 unknowns class, we're going to represent them as x and y. Thank you, Maddie. I saw your lips move. X and y. And so we just need to make 2 equations now. Before we pick one to be x and we figure the equation from there, we're going to make 2 equations. The first sentence is our first equation. At your seats, represent that the large number is 1 more than 5 times as large as a small number. Represent that a large number is 1 more than 5 times as large as a small number. And what did you write, Kendall?
X equals 5y plus 1.
Good. X equals 5y plus 1. How many have the same equation? Or 1 plus 5y means the same thing. All right, we're going to do the same with the second sentence now. That's going to form our second equation. If 10 times the smaller number is subtracted from, going back to the beginning of the year, the from comes first. Say that with me, class. The from comes first. Again? That's an important thing to remember. All right, so if 10 times the smaller number is subtracted from 3 times the larger number, the remainder is 38. Represent that equation. And we'll get it from Genesis as she's writing it.
10y minus 3x minus 10y.
Good, 3x minus 10y.
Equals 30.
There we go. How many of the same equation that Genesis had for the second one? And now it's just a matter of solving. Now it's really set up for you to solve by substitution, but you could rig it pretty easily to go addition or elimination at your seats. Go and finish the system out. Find the 2 numbers in question. And once you're done, check your answers. How many got those 2 numbers? Any questions at all on that? Let's take a look at another one. Here's a problem we probably haven't seen since Algebra 1. I don't think we've done investment problems yet this year. Read the problem for us if you would, Michael, and then we'll talk about this.
A high school junior invested $2,500, which he had earned in 3 years of mowing lawns. If he invested some at 3% and the rest at 2%, and the annual income from both investments was $55, find the amount of each investment.
Now you understand, if you put this $2,500 into a savings account, you'll earn about 16 cents if you put it into a savings account these days. Okay, savings accounts earns nothing, but there are special savings accounts that you can put your money into which would earn a little bit better interest, and that's what we've got here, probably certificates of deposit or something like that. So say, I'm not going to need this money, I'm setting it aside for college, which by the way would be a really good idea for you if you haven't started yet, especially you. All right, we're setting money aside for college, right? And so he puts some in a certificate of deposit where he can't touch it for a while, gets 3% interest, another one where he gets 2% interest, and that sounds like really low interest rates, but they're actually really good these days because interest rates are horrible when you're trying to make money. So with this, we remember in making interest, thinking back to our junior high days even, we had a formula to find interest. Call it the simple interest formula. What was that?
I equals PRT.
Yeah, I equals PRT. How many now that he's saying, oh yeah, I remember I equals PRT? I, of course, class stands for interest. Okay, that's the money you're hoping to make if you're investing money or saving money. It's the money you hate to pay if you're borrowing money, like on a credit card. P is the
Price.
Well, the principal. It's the amount of money that you're investing or the amount of money you're borrowing, depending on your perspective. R stands for the rate, which is always a percent, which means it has to be written as a decimal, right? 2 decimal places. And then T stands for time, which is measured in years. Time is going to be measured in years. So here's what we can do. We worked problems earlier, remember, where we had a little bit of a chart set up. This was right at the end of the first semester. We can do this here if we say that the principal times the rate times the time is equal to interest. Principal times rate times time equals interest. And there's 2 different accounts. There's a 2% account into which he put money, and then there was a 3% account. I don't know how much of his money he put in this account. That's what it's asking. Find the amount of each investment. How much money was put into each of these investment accounts? Well, I don't know. So since I don't know, class, I could call this. But I don't know this either, so let's call this Y. I definitely know the rate, 2%. But I'm not going to write 2%, class. I'm going to make it a decimal. 0.02. This should be written 0.03. What about time? What reference is there to time in the word problem here?
3 years.
Well, that's true. It does mention that. That's not how long he's invested the money, though, right? He mowed lawns for 3 years, and then he invests the money he made. What does it mention about the time that the investment sat there?
1
year. It doesn't say a year, but it says annual, which implies 1 year. All right, so the time is 1. Well, at that point, we could really kind of ignore it, couldn't we? So, if principal times rate times time equals interest, how much interest does he make off of the X dollars, however much it is, that he puts in the 2% CD, presumably? 0.02x. And if he invests Y dollars at 3% interest for a year, how much interest does he make off of it? This is the money he invests. This is the money he makes off of his investment. This is the money the government will tax him on, because they've already taxed him on it. Anyway, all right, so X and Y. So here's the deal. If X and Y are the amounts that he invested, we need to find the number that is the total investment. How much did he invest, class?
$2,500.
$2,500. So I'm going to set up 2 equations here. The first equation is that X plus Y equals $2,500. Money invested plus money invested equals the total amount of money invested. Does that make sense? The other number I'm given, I've got a number of investment and I've got a number of interest income. Well, this is interest income. Interest income and more interest income is going to equal $55. So my lower equation, class, becomes 55. Make sense? Principal plus principal equals principal. Interest plus interest equals interest. And there's my system of equations. And you can work virtually any investment type problem this way, just using your chart setup that we used before, but now with X's and Y's. So we're going to have 2 equations, not 1. Now I do really hate decimals, but it's easy to take care of this problem. Class, just move the decimal 2 places. This becomes a 2x, this becomes a 3y, and this becomes 5,500, 5,500, as I move the decimal 2 places on every one of those. Any questions on what I've done so far? All right, solve. So I was lazy. I multiplied the top by a 3 to get 3x plus 3y equals $7,500. Changed all the signs across the bottom to get x equals 2,000. So there's $2,000 in the 2% account. And then, well, you invested $2,500, so if 2,000 went here, that leaves 500 to go there. How many got those answers? All right, questions on this? Questions on this? So look at one more word problem, and then we'll go on to something else. And another interest problem here. Read this for us, if you would, Kendall.
A credit card company distributed to clients 58,000 in cash advances, which immediately began earning interest, some at 21% and some at 18%. If the customers do not pay back the money for 1 year, the company will make $11,640 income on the advances. How much do they owe at each rate?
All right, so you can get cash to your credit card, but you pay massive interest on it, and that's what we've got going here. Some people are borrowing, a number of different people are borrowing a total, a conglomerate of $58,000. Now, credit cards charge different people different rates. If you've got really good credit, meaning you pay all your bills every month, and you've been doing that for a while, you get a decent interest rate. Decent, like 18%. And if you don't pay your bills on time, you get rotten interest rates like 21% or 29% in some cases. Interest rates vary depending on the credit cards. So we've got some customers who are charged 18% interest on the cash advances, some 21% interest. So two different groups of people, if you will. Well, we've got the 21% folks and we've got the 18% folks. The credit card company is loaning out or investing, is how they would think of it. From the client side, we think we're borrowing the money, right? We're taking the money and paying huge amounts of interest on it. There's a certain amount of principal being borrowed or loaned out. Obviously, we have the rate. And again, the time it references as being, we don't pay back the money for a year. So I'm not even going to waste my time putting the time column. Does that make sense? And then, so I'm just going to say principal times rate, ignore the time, it's 1 anyway, is equal to interest. Well, I don't know how much of the money, the $58,000, went to the 21% people, and I don't know how much of the $58,000 went to the 18% people. So let's call those unknowns, class. X and Y. I do know the rate that the 21% people are charged, 0.21, and the rate that the 18% people are charged, 0.18. So I know how much interest the 21% people paid total, 0.21x. And I know the interest that the 18% people paid total, 0.18. Now, I got to make two equations. Two numbers I haven't used, $58,000 and $11,640. The $58,000 is the amount that is loaned out. Class, we call that principal. Money that is loaned out or money that is borrowed, depending on your perspective, right? Like if Michael loans Genesis, $10, he's loaning the money, she's borrowing the money, but the $10 is the principal, right? It's the money that changes hands. The total principal is $58,000. At your seats, write an equation based on the fact that the total principal is $58,000. Write an equation that shows that the total principal, total money borrowed or loaned out, was $58,000. And Maddie, what did you write? Yeah, x plus y equals 58,000. Because that's the principal. The other number we haven't used yet, class, is the 11,640. And somebody upstairs, I think it's Mr. McDonald, is shaking the floor and therefore my projector. $11,640. Well, that's the income that the credit card company makes. The income that they make, we call interest. It's what you pay. That's how they make money, right? You pay them interest. That's income for them. So if this is interest, then at your seats, class, write an equation that shows that the interest the company made off these people was $11,640. And Genesis, what's your equation?
Do you want to know what the decimals are?
Yes. We'll do it with the decimals for now.
Okay. 0.21 plus and y equals 11,640.
There we go. How many of the same second equation? 0.21x plus 0.18y equals 11,640. Now, in reality, if you said, I know I'm going to remove the decimals anyway, why would I waste my time writing them? I can't entirely disagree with that. As long as you remember to move it twice here, and twice here. So don't forget to tack on those extra 2 zeros, and if you're a comma person, move the commas. At your seats, solve. Let me get my calculator. man, these answers. $40,000 at 21% and $18,000 at 18%. All right, I went and multiplied the 21 through the top, changed signs across the bottom, got the 18,000, and then it was like, oh yeah, 58,000 total. If 18,000 of that's there, the other 40,000 is to the 21% people. Questions on interest problems? Now, I've got a chance to see a couple of them worked. All right, new thing that I'm going to work on more next week with you, but want to introduce to you today is one more deal with these rational equations, but where the variables are in the denominator. Write the system of equations down in your notes, if you would, please. 15 over x plus 4 over y equals 6. And also 6 over x minus 12 over y equals negative 1. Now technically, if you're creative, you could find a way to work with this the way it's written. I hate fractions. And ordinarily, because I hate fractions, class, I'll multiply everything by the LCD, which would be xy. And you realize if you multiply by xy, the x's cancel, you get 15y. Y's cancel, you get 4x and 6xy. Well, what in blazes are you supposed to do with a 6xy? You haven't done that before. That presents a little bit of a problem. So my suggested strategy, if there are variables in the denominator, is use a process that I call UV substitution. UV substitution. Nothing special about the letters U and V any more than X and Y, except they don't really look like anything else in the alphabet, which is nice. Here's what I'm going to do. I'm going to say that U is going to be the reciprocal of X, and V is going to be the reciprocal of Y. I'm going to let U represent the reciprocal of X, and V represent the reciprocal of Y. Here's the idea. 15 over X means the same as 15 times 1 over X, correct? It's the same thing. If 1 over X is being represented by the letter U, then 15 over X, or 15 times 1 over X, just becomes 15U. Fraction gone. 4 over Y is the same thing as plus 4 times 1 over Y, correct? So if V is representing 1 over Y, then 4 over Y becomes 4V. Fraction gone. And I don't even have to mess with the 6 because there aren't any X's and Y's in the 6, so I don't mess with the 6 because U and V are only used to represent reciprocals of X and Y. Well, in that case, following the pattern, how do you suppose we'd write 6 over X, class? 6U. 6 times the reciprocal of X, or 6U, because U is the reciprocal of X. I'm choosing to represent it that way. So a negative 12 over Y, class, could become negative 12V. And I don't have to mess with the negative 1. It can stay a nice, easy negative 1. And then I can solve this the way I would any other system of equations now. I probably multiply the top class by 3. And that'll get me a 45U, you're doing this with me, plus 12V equals 18. Bottom equation, I'm going to leave it alone. 6U negative 12V equals negative 1. Now the V's are going to cancel. What do I get for my U's? 51U is equal to 17. Divide away the 51. Put that in your calculator and see if it'll reduce. Okay, it does, 1/3. That's not too bad of a fraction, especially considering plugging in a third here. You can take a third of 15 or a third of 6 pretty easily. I'm going to take a third of 15. What is a third of 15, class? 5. Move the 5 over as a negative 5 to get 4V is equal to 1. Therefore, what is V, class? 1/4. U is a third, V is a fourth. But I don't want to solve for U and V, I want to solve for X and Y. Well, remember, U is the reciprocal of X, right? Therefore, X is the reciprocal of U, right? Numbers are reciprocals of each other. So if U is 1/3, X is the reciprocal of that. Well, what would X be then, class? 3. If V and Y are reciprocals, and V is a fourth, then Y, class, is 4. And so my answer is 3, 4. I get rid of the fractions by literally replacing denominators of x and y with u's and v's that aren't denominators anymore. Gonna do one more, stay with me. I know I'm going just to nudge past the bell, but I want you to be prepared for your homework. Write this down if you would, please. 5 over x plus 4 over y equals 13, and 2 over x minus 3 over y equals negative 4. Again, when there are variables in the denominator, you don't multiply by the LCD, it's going to mess you up. Just replace denominators of x and y, class, with u and v. So how might I rewrite my top equation here, Michael?
5u plus 4v equals 13.
Yeah, 5u plus 4v equals 13. What about the lower equation, Genesis?
2u minus negative 3v equals negative 4.
There we go. And Audrey, we want to...
Multiply by 3 and 4.
Okay, so 3 on the top, 4 on the bottom. That's going to turn my system into what?
15u plus 12v equals 39.
And the lower equation?
8u minus 12v equals negative 16.
And of course the v's will cancel. We'll add the u's, class.
23.
23u equals 23. Oh, well, that's interesting. U, class, is equal to 1. Don't go back to the original. Remember, stay here for now. Let's go ahead and get the v. Plug the 1 in for the u. 5 times 1 is, subtract it to get, divide by 4 to get, v equals 2. But 1, 2 is not my answer. I want x and y. And x is the reciprocal of u. Y is the reciprocal of v. So what is x, class? Well, the reciprocal of 1 is 1. What is y, class? 1/2. The reciprocal of 2 is 1/2. So my answer is 1/1/2. Questions on the UV substitution? Because you have one of these in your homework this evening. Any questions? All right, homework for this evening is to complete a handout. It's in the description of the video if you're watching on YouTube. So complete this handout for homework this evening. Also get to practice with an interest word problem. So get a chance to practice that as well. Typically this on Monday, and then we will continue working on problems like these on Monday. Have a wonderful rest of your day, and you are dismissed.